All right, we are here to do a walkthrough of practice quiz number 2 for learning target number 7, solving equations, inequalities, and systems. I'm going to do my best to write legibly here. There's a lot of work to be shown to do this well. Show your work. It's a lot of steps, a lot of chances to make a mistake. So let's break this down. First one, we're going to solve some equations. Square root. Our first step, we want to isolate what's under the square root. We want to isolate the square root portion. So we got to get square root of 5x minus 6 by itself. Let's start by subtracting 7 from both sides. Yeah, I'm going to write pretty small because I got to fit a lot of stuff here. Do that. We get 3 times the square root of 5x minus 6 equals 21. Let's divide both sides by 3 to get the square root of 5x minus 6 equals 7. Once I've got that square root by itself, I'm going to square both sides. Square both sides. What that means is I'm doing the opposite of a square root. That cancels out the square root, so I'm left with 5x minus 6 equals 42, a linear equation that we can solve. Let's add 6 to both sides. All right. Why did I write 42? That's 49. Confusing myself here. 7 squared is 49, my bad. And 5x, 49 plus 6 is 55. Divide both sides by 5. We're going to get x equals 11. Now, we need to check and just be careful. Is x equals 11 an extraneous solution? Plug it back in. 5 times 11 is 55, minus 6 is 49. Positive 49. Square root of that is 7. 3 times 7 is 21, plus 7 is 28. Careful if you get some negative numbers down here. You want to go back and check and make sure they work. That's a square root. Let's go on to absolute value. Absolute value, again, first step, get the absolute value isolated. We can see here, it already is. The only thing here is the absolute value of 9 minus 2x equals 3x. Once you have the absolute value isolated, we set up 2 equations. Either 9 minus 2x equals positive 3x, whatever on this side is positive, or 9 minus 2x equals negative 3x. It doesn't work any differently because it's not a number over here. Doesn't matter, it's a coefficient and a variable. It's still the positive or the negative. Now let's solve both. All right, let's add 2x to both sides. And we're going to get 9 equals 5x. Divide by 5, divide by 5. And we are going to get 9 over 5, 9/5 equals x. On this side, do the same thing. Add 2x to both sides. We're going to get 9 equals negative 1x. Divide by negative 1. Or negative 9 equals x. Those are our 2 answers right there. Okay, great. First 2 down. Now let's move on to our rational equation here. First step, we want to figure out what is the lowest or least common denominator. I like to write it out for myself. Well, in this case, I've got x over 1, x minus 3, and x minus 3. What do 1, x minus 3, and x minus 3 all go into? X minus 3. So that's what I need to multiply across everything. X minus 3. So what's that going to become? That's going to become x times x minus 3 plus 6 times x minus 3 equals 2x times x minus 3. Right. Don't forget that this is over x minus 3, over x minus 3, and this is just over 1. All I did again is multiplied the numerators all by x minus 3. Here, here, and here. Now, let's simplify. X times x minus 3 over 1 is x squared minus 3x. The x minus 3's cancel out, so I get plus 6. The x minus 3's cancel out, so I get 2x. Your next clue here should be because this is a quadratic, I know I need to get it equal to 0. So I'm going to subtract 2x from both sides to get x squared minus 5x plus 6 equals 0. Because they're quadratic, I can either use quadratic formula or I can factor it and use zero product property. I like to factor in zero product property. I just think it's quicker. So this factors right here into x minus 3 times x minus 2 equals 0. That's not true at all. Yes, it is. Right? X squared minus 5x plus 6. What multiplies to 6 and adds to negative 5? Yeah. Okay, great. So then I solve each of those, either x minus 3 equals 0 or x minus 2 equals 0. Add 3, add 3. So I'm going to get x equals 3. Add 2 or add 2. I'm going to get x equals 2. Okay. So from there, I need to check, are either of these answers extraneous? Extraneous means it doesn't work if I put it back. Well, if I put x equals 3 as back, 3 plus 6 over 3 minus 3. Alarm bells should be going off. 6 over 3 minus 3, that's like 6 over 0. I cannot divide by 0. So this one is extraneous. So our only answer is x equals 2. That's our only answer, x equals 2. All right, there is level 1. Moving on down here, level 2. All right, for level 2, let's solve the system. All right. So first step, let's line up our x's and our y's. Negative 3x plus 12y equals 0. I'm going to try to eliminate the x's, so I am going to multiply to make opposites. I'm going to multiply by this by a 2 to make a negative 6. I'm going to multiply the top one by a negative 3 to make a positive 6. When I do that, negative 3 times negative 2x is 6x minus 24y equals negative 18. 2 times negative 3x, negative 6x plus 24y equals 0. You may see where this is going. Add them together. Cancels, cancels. 0 equals negative 18. Is that a true statement? No, it's a false statement. It's not true, which means no solutions. Okay, no solutions. Next one. I see I've got a quadratic and a linear, and I see they are both equal to y. Then in that case, I'm going to substitute the other equation in for y to get negative 2x plus 1 equals x squared plus 2x plus 1. Now again, because this is a quadratic, I know I need to get it set equal to 0. So let's add 2x to both sides. So I get 1 equals x squared plus 4x plus 1. Now I'm going to subtract 1 from both sides to get 0 equals x squared plus 4x. Don't forget, because it doesn't look like a normal quadratic. What's your first step when you factor a quadratic? Greatest common factor. Here, our greatest common factor is x. So if I factor out an x, divide out an x, x times x equals x squared. 4x divided by x equals 4. What are our solutions here? Either x equals 0 or 0 equals x plus 4. Subtract 4 from both sides. So x equals negative 4. Are we done? No, it's a system. We need x and y. So if I take this 0, substitute it back in, y equals negative 2 times 0 plus 1, y equals 1. One of my solutions is at 0, 1. This line and this parabola intersect at 0, 1. They also intersect at negative 2 times negative 4 plus 1. So y equals 8 plus 1 is 9. They also intersect at negative 4, 9. So there is standards 7.1 and 7.2. Let's flip to the back side. First thing we're going to do here is to solve a system of 3 variables. So step 1, we want to eliminate one variable here. We want to eliminate one variable. My first step here is I'm going to eliminate x because I see it looks like I can eliminate z right away too. But if you notice this third equation, there's no x right there. It's already gone. Right? There's no x. So if I can eliminate x from another set of equations, I can just use this one. It's already done for me. So I'm going to take the top two and I'm going to eliminate x. So I'm going to rewrite them here. 6x plus y plus z equals negative 13. 5x plus 3y minus z equals negative 1. Easiest thing to do in these, easiest mistake to make in solving these systems, lack of precision. Be careful. Take your time. So I'm going to eliminate the x's. So what do 5 and 6 both go into? They both go into 30. I'm going to make opposites. Multiply the top one by 5 and the bottom one by 6. what do they become? Negative 30x plus 5y plus 5z equals negative 65. And the second equation becomes 30x plus 18y minus 6z equals negative 6. Add those two together. Okay. And I'm going to get 23y minus z equals negative 71. Again, what was the purpose of this? I want to eliminate x. Because now, step 2, I want to solve the system for y and z. I have a system of two equations with just y and z in them. 23y minus z equals negative 71. And then I have this one right here, right? Negative 6y plus 2z equals 22. Well, I want to make opposites here. So I see a 2z and a negative 1. So I'm going to make this one become a negative 2z by multiplying it by 2. So that becomes 46y minus 2z equals negative 142. Use a calculator if you need it. And then I have my second equation, negative 6y plus 2z equals 22. Add them together. 46 minus 6 is 40y. Negative 2 plus 2z cancels. Negative 142 plus 22 is negative 120. Solve for y, divide by 40. Y equals negative 3. Okay. Once I've got y, I'm going to solve for z. So negative 6y plus 2z equals 22. I now know y right here is negative 3 plus 2z equals 22. So negative 18 plus 2z equals 22. Oh, that should be plus 18. Sorry, positive 18. Negative 6 times negative 3 is positive 18. You got to be careful for that. All right, right there, I almost made a mistake because now I need to subtract 18 to get 2z equals 4. So z equals 2. I've got y. I've got z. Third step, solve for x, our last variable. So we're going to take one of our original equations, negative 6x plus y plus z equals negative 13, and we're going to substitute in for y and z. I don't know x. I know y is negative 3. I know z is 2. And I know that equals negative 13. If we work this out, negative 6x minus negative 3 plus 2 is negative 1 equals negative 13. Add 1 to both sides. Negative 6x equals negative 12. Divide by negative 6. And x equals 2. So my final answer here is x comma z equals 2, negative 3, 2. Long process, but just go one step at a time. Be careful on each step. Let's talk about standard 7.4, solving system of inequalities using graphing. First step, let's graph this. I'm going to graph this square root function. Y is greater than the square root of x plus 4 plus 1. Because I see this greater than, that means I'm going to use a dashed line. It is not inclusive. X plus 4 plus 1. Remember your parent functions. X minus h plus k. This means h is 4 to the left. 1, 2, 3, 4, and up 1. Your growth pattern from there goes over 1, up 1, over 4, up 2, over 9, up 3. Now again, it's a dashed line because it is greater than, not greater than or equal to. For the parabola, it's a solid line because it is greater than or equal to. Now remember your parabola general form here, a times x minus h squared plus k. Our vertex we can see is at negative 1, comma negative 7, negative 1, negative 7 right there. And our a value is 2, so we go over 1, instead of over 1, up 1, we go over 1, up 2. over 2. Instead of up 4, we go up 8. Right, and that's about good enough. You get the idea. Again, it's a solid line because it's inclusive. Now, we need to test a point to see should we shade above or under the square root function. We need to test a point to also see if we should shade inside or outside of the parabola. So let's test 0, 0. Test 0, 0. So is 0 greater than the square root of 0 plus 4 plus 1? Is 0 greater than the square root of 4 plus 1? Is 0 greater than 2 plus 1? Is 0 greater than 3? No. So we are going to shade the region that does not include 0, 0 for the square root. So we know we're shading above the square root. 0, 0 does not work as a solution for this inequality. So we have to shade above. Now let's test it for the parabola. Is 0 greater than or equal to 2 times 0 plus 1 squared minus 7? Is 0 greater than or equal to 2 times 1 squared minus 7? Is 0 greater than or equal to 2 minus 7? Is 0 greater than or equal to negative 5? It is. So we need to shade inside the parabola. This means we're going to shade inside parabola. This means we're going to shade above square root. So above the square root and inside the parabola means we're shading this region. Anywhere in here will be a solution to both inequalities. Okay, that is practice quiz number 2 for LT number 7. Hope you found this helpful. Check Canvas for more resources.